Welcome back. In this lesson, we're going to be looking at how data is transmitted from one device to another using different methods of data transmission. In addition to that, you should also be able to explain the suitability of each method of data transmission for a given scenario in the exam. Now, data transmission methods have two parts. One is the direction of travel, and the second one is the method of transmission itself. We'll start by looking at the direction of travel. The first one we're going to look at is the simplex data transmission method. Now, this is transmission in one direction only. Examples include data that's sent from a microphone to a sensor to a computer to a speaker, a computer to a monitor, a webcam to a computer. Now, these are only one way because you don't want data coming back. So therefore, this is called simplex data transmission method. Now, in some exams, you're asked to draw a diagram. And if you are drawing a diagram, you will have a sender and a receiver, and you will just draw a single line between the devices to indicate one direction of travel. The second direction is called half-duplex, and half-duplex is data transmission in both directions, but not at the same time. So it's kind of like a walkie-talkie where you just talk once. So you say the word over before the next person begins. Another example is citizens band radio, which is used by truckers and other people. And you represent that in a diagram by having two devices and drawing two arrows, one in each direction. The final direction is duplex. And duplex data transmission occurs in both directions simultaneously. So when we're having a live telephone call, both people can talk over each other. Voice over internet protocol, for example, that used in Skype or Zoom calls, that is also duplex. Video conferencing, instant messaging are other examples of duplex data transmission. You can draw the diagram by having a sender and receiver which has one line with arrows on both ends. This indicates transmission simultaneously. Now those were the directions: simplex, half-duplex, and duplex. The methods of transmissions are serial and parallel. Now, serial data transmission is when data is sent one bit at a time over a single wire or channel. Bits are sent one after the other, so it's a single stream. Bits can be transmitted as simplex, half-duplex, or duplex. In the exam, you'll be asked to justify a combination of direction and method together. Now, this method of transmission works well over long distances. However, data is transmitted at a lot slower rate than parallel data transmission. Now, using a single wire gives additional benefits. For example, there's less chance of interference, so little or no data corruption occurs. Using a single wire also reduces cost, and the bits are always synchronized during transmission because they are following one after the other. There's no need for reorganizing anything. Examples of serial data transmission are sending data from a computer to a modem, or transmission over a telephone line, or from a keyboard to a computer, from a microphone to a computer, and so on. The next method of transmission is parallel. Parallel data transmission is when several bits of data, usually one byte at a time, are sent down several wires or channels at the same time. One wire or channel is used to transmit each bit. Now, this method of transmission works very well over shorter distances because over longer distances, bits can become skewed, which means they will no longer be synchronized. That means one bit might arrive ahead of the other one, and that could change the entire meaning of the data that you're transmitting. This method is faster than serial data transmission because you're sending multiple bits at the same time. So this type of transmission is generally used in the internal electronics of a computer system. The pathways between the CPU and the memory all use this method of data transmission. Integrated circuits, buses, and other internal components also are likely to use a parallel data transmission method. And the reason for this is because of the high-speed nature of data transfer. Examples include sending data to a printer from a computer as well, using something called a ribbon connector, and you can see that in the top right-hand corner of the screen. Now, this type of method can also be used in simplex, duplex, and half-duplex variety as well. On screen, you can see a comparison between serial and parallel. Serial, you have less risk of external interference. There's more reliable transmission over longer distances. Transmitted bits won't have the risk of being skewed. That means they won't be out of sync. It's used if the amount of data being sent is relatively small, since transmission rate is slower than parallel. An example is that USB uses this method of data transmission. It's used to send data over longer distances, for example, telephone lines, and it's generally less expensive than parallel due to fewer hardware requirements. For parallel, it's a faster rate of data transmission than serial. It works very well over shorter distances, for example, inside a computer or just less than 5 meters. Since several channels or wires are being used to transmit data, the bits can arrive out of sync. It's the preferred method when speed is important or if data is time sensitive. Parallel ports require more hardware, making them more expensive to implement than serial ports. However, it's easier to program input and output operations when parallel is used compared to serial methods. Make sure you remember a few differences between both because this type of question is quite common in the exam. That's all for today. Hopefully you can answer the following questions as well. What are the two common methods of data transmission? What are the three directions of transmission? You should be able to compare serial and parallel data transmission. And you should be able to answer questions which are based on a scenario. For example, Arvind wants to send data to his games console, which is less than 5 meters away. What type of transmission direction and method will you recommend? And finally, you should be able to compare serial simplex and parallel half-duplex or a variety of combinations and be able to justify your reasoning. Other combinations could include serial half-duplex, serial duplex, or parallel simplex, and so on. That's all for this particular lesson. If you do have any questions, please get back to me. Otherwise, I'll see you in the next one.